Next predictor is destination. So once again, set up a pivot table. Let's put that right here. And destination goes into the rows, and again flight status, and carrier. So it's a format this. We need to format that too. Okay, so destination here would be B52, and the probabilities are C52 divided by C55, an absolute reference in this fashion, so we can just simply copy that formula, and now we have the conditional probabilities for destination. So that would be count of destination. Next is origin. Okay, so destination is done. So let's do origin next. Origin, and rows, flight status. Okay. So this is count of origin. I keep forgetting. Okay, origin would be B59. Then the probabilities are C59 divided by C62, and absolute reference properly. Okay. And then the last predictor we want to use. If you want to use more predictors, you can keep going like this. So the last one is weather, whether inclement or not. There are only two possible values there. So here. And see, here it is. At this point, you need to change the options. So then the column width will not change. So uncheck auto fit, then column width will not change. So now weather, all right, and then flight status. Okay, so now just that. Okay, so B66, okay, and then C66 divided by C68. Like that. Okay, properly absolute referenced. All right, so now we have all the conditional probabilities. Okay. Now what we need to do is to find the joint probability. Okay, we need to set up the conditional probability. probability that carrier is DL given delayed, DL given on time. Day of the week equal to 7 given delayed here, given on time here. So once you assemble all that, then the marginal probability, well, the joint probability first and then the marginal probability. So the joint probability, so that should be joint probability first and then marginal probability. So joint probability will be the product of all that and the marginal, oh, that's what I had there, marginal probability. Okay. That marginal probability out here. Okay. Well, so let me put it back to where it was. I had it okay. So now let's assemble the probabilities. Okay. So first one is carrier equal to DL. So which is right there. Okay. And then copy that. So this is probability of DL given delayed. This is probability of DL given on time. I used VLOOKUP, but that's fine. So if you use VLOOKUP, then we can change the profile and these probabilities will automatically change. Okay. So let's do it that way then. So we have, if we do VLOOKUP, right? So look up this value. For the first one, it is the lookup table is that. Okay. And make sure that it is absolute referenced. And then the column to look up, if it is delayed, it is column 2. If it is on time, it is column 3. So G72 should be absolute reference to the column. All right. So then day of the week, so that's your lookup value, and that should be absolute reference to the column. And day of the week is right here. Okay, absolute reference that. And then the column to look it up is that. Copy that over. And then departure time is lookup value okay, and that's the lookup table, and that's the column. And here we need to do one more thing. So we want the exact value, because this I think won't work. Oh, did okay. But actually I think it's better to put exact match. You want exact match, so it should be false. Oops. False should be 0. Okay. Then you copy that over. And then we look up that one. Destination is that, and lookup value and origin start. I forgot to put the dollar sign there. That's we look up that one. That. And that. Okay. So these are the conditional probabilities. Then the marginal probability for delayed and on time. Okay, we have that way at the top, right? So that's the marginal probability. So assemble that. Then the product of all that. Okay, see, this is the formula that we saw. Like here, see, conditional probability times conditional probability, and then the marginal probability. So now in the small example, with there are only two possible values, two possible predictors, and so two possible conditional probabilities, and then the marginal probability. But in this problem, we have several predictors, so we have one conditional probability for each predictor, and then finally the marginal probability. So when you do a product of all of that, so now you're multiplying all the conditional probabilities and then finally with the marginal probability. Okay. So that's our joint probability, okay, which is an estimate. Okay, joint in exact naive, but the exact Bayes method, we would have found the joint probability of this directly from the data set. But in naive, we are using an approximation by finding the conditional probability for individual values and then doing a product of that, multiplying with the marginal as an approximation for the joint probability. So these two joint probabilities are approximations. Yes?
Will you show the equation for marginal probability in Excel?
Here?
Yes.
Okay, so this comes from way at the top.
Oh.
So we already did the marginal probability. So marginal probability here is probability delayed, probability on time. So the 428 divided by 2201 and then 1773 divided.
So what's the joint probability?
Okay, joint probability is the product of all that. So this is the joint probability of this predictor profile, and that's just a product of this whole thing. Okay, so joint probability of all these values for values and being delayed, and this is the joint probability of all of these values for the predictor variables and being on time. So now when you add these two, that's your marginal probability. That's the marginal probability for this predictor profile. Okay. So now the reverse conditional probability, that is given these values for the predictors, what is the probability that the flight will be delayed? So that will be the joint probability divided by the marginal probability. So for this predictor profile, the propensity is 0.0585. Probability that this event will happen. Event here is defined as the flight being delayed.